Right now, as you listen to this, something is passing through you, not around you, through you, through your skin, through your bones, through the very atoms of your body. An invisible substance is streaming, silent and untouchable, and it does not slow down, and it does not stop, and you cannot feel it, and you cannot see it, and you have never once in your entire life been aware of it. It is passing through the walls of the room you are in. It is passing through the floor and the ceiling and the ground beneath the building. It is passing through the entire planet, as if the Earth, all 8,000 miles of solid rock and molten iron, were made of nothing at all. And here's the part that should stop you cold. This invisible substance is not rare. It is not some exotic trace. It outweighs everything you have ever seen, everything you have ever touched, every star in the sky and every grain of sand on every beach, by a margin so vast that the visible world, the only world you have ever known, turns out to be the tiny exception. We are the minority. We are the thin, bright film floating on the surface of an invisible ocean, and almost everything that the universe is actually made of is a thing we cannot see, cannot touch, and to this day cannot name. Tonight we are going to confront one of the most disturbing facts in all of science, and it is disturbing not because it is loud or violent, but because it is quiet and total, and it has been true your entire life without you ever suspecting it. We are going to learn that the cosmos you think you understand, the one you can see with your eyes and study with your telescopes, is only a sliver of what is really out there. We are going to follow the story of how a single difficult, brilliant, abrasive man noticed something wrong with the way galaxies move almost a century ago, and how he was ignored and ridiculed for decades before the universe proved him right. We are going to see the evidence pile up, piece by undeniable piece, until there was no escaping the conclusion. And we are going to sit with what that conclusion actually means, which is that we have been wrong, profoundly and fundamentally wrong, about what most of reality is even made of. Not wrong about the details, wrong about the bulk, wrong about the majority, wrong about the thing that holds every galaxy together, including our own, including the one cradling the star that keeps you alive. But before we can talk about the invisible ocean, we have to start with the man who first felt its pull. And to understand him, you have to understand how certain the world was back then, that it already knew what the universe was made of. In the early decades of the 20th century, astronomy was in the middle of an extraordinary expansion of its own understanding. Astronomers had only recently realized that the faint smudges of light scattered across the sky, the ones they had once thought were clouds of gas within our own galaxy, were in fact other galaxies entirely, vast islands of billions of stars, unimaginably far away. The universe had suddenly become enormous, far larger than anyone had dreamed, and astronomers were busy mapping this newly vast cosmos, measuring the galaxies, weighing them, working out how they moved. And in that confident, expanding science, almost everyone assumed the same simple thing. They assumed that the universe was made of the stuff they could see: stars, gas, dust, the luminous material that gave off light or blocked it. Of course, the universe was made of what we could see. What else would it be made of? The idea that there might be some enormous, invisible component, something that vastly outweighed all the visible stars and yet gave off no light at all, would have seemed not just unlikely, but almost absurd. The universe was the things that shone. Everyone knew that. Into this confident world came a man named Fritz Zwicky, and Fritz Zwicky was not a man who cared very much what everyone knew. He was a Swiss astronomer working in California, and by every account, he was a genius and a nightmare in roughly equal measure. He was brilliant, original, decades ahead of his time on a startling range of ideas, and he was also famously difficult, combative, and contemptuous of colleagues he considered fools, which was most of them. He coined insults for the astronomers he disliked, calling them, in one famous phrase, spherical bastards, by which he meant that they were bastards no matter which way you looked at them, from any angle, in every direction. He was not a man who built consensus. He was a man who looked at the data, trusted his own mind over the opinions of others, and said exactly what he saw, whether or not anyone wanted to hear it. And in the early 1930s, what he saw was something that did not make sense. Zwicky was studying a great swarm of galaxies called the Coma Cluster, an enormous gathering of hundreds upon hundreds of galaxies, all bound together by gravity, all orbiting around their common center like bees around a hive. And he set out to do something that sounds simple, but is profound. He set out to weigh it. There are two ways to estimate the mass of a cluster of galaxies, and the beauty of the situation is that if you understand the universe correctly, the two ways should agree. The first way is to add up all the light. You count the galaxies, you measure how bright they are, you know roughly how much mass it takes to produce that much starlight, and you add it all up to get the total mass of everything visible. The second way is to measure how the galaxies move. In a cluster bound by gravity, the speed of the galaxies depends on the total mass pulling on them. More mass means stronger gravity means faster speeds. So if you measure how fast the galaxies are whipping around, you can work backward and calculate how much mass must be there to hold them in their orbits, to keep them from simply flying apart and scattering into the void. Zwicky measured both. He added up the light, and he measured the motion. And the two answers did not agree. They did not agree by a little. They disagreed by an enormous, staggering amount. The galaxies in the Coma Cluster were moving so fast, whipping around so violently, that the gravity from all the visible matter, all the stars and gas he could see and count, was nowhere near enough to hold them together. By the visible mass alone, the cluster should have torn itself apart long ago, the galaxies flinging off into space in every direction. But there it was, intact, bound, holding together across billions of years. Something was holding it. Something with far more gravitational pull than all the visible matter combined. Something he could not see. Zwicky did the only thing an honest scientist could do. He followed the numbers to their conclusion, however strange. If the visible matter was not enough to hold the cluster together, and yet the cluster was clearly held together, then there had to be more matter present than he could see. A great deal more. Matter that gave off no light, that did not shine and could not be photographed, that announced its presence only through the gravity it produced. He gave it a name in his native German. He called it Dunkle Materie, dark matter, and his calculations suggested that there had to be far more of this dark matter than visible matter, that the glowing galaxies were merely the small, bright tip of something vastly larger and entirely unseen. It was, in retrospect, one of the most important discoveries in the history of astronomy. He had found the first evidence that the universe is dominated by something invisible, and the response from the scientific community was, for the most part, silence, a shrug, a turning away. The idea was too strange, the man too abrasive, the implications too uncomfortable. Most astronomers simply did not take it seriously. Perhaps there was some error in the measurements. Perhaps there was ordinary matter hiding in some form they hadn't accounted for. Cold gas or faint dead stars. Perhaps Zwicky, difficult Zwicky, had simply made a mistake. The notion that the universe might be mostly composed of some unknown invisible substance was not the kind of thing a careful scientist wanted to stake a reputation on. And so the discovery sat there, in the published record, largely ignored, for decades. Zwicky had seen the edge of the invisible ocean, had felt its pull, had even given it a name. And the world looked away. There is something haunting about that gap, those decades of silence. The truth was sitting there the whole time, written into the motion of the galaxies, available to anyone who cared to look. The universe was telling us, plainly, that it was mostly made of something we could not see, and we were not ready to hear it. We were too attached to the comfortable assumption that the cosmos was the things that shine. It would take a generation and a completely different line of evidence gathered by a completely different kind of scientist before the world was finally forced to listen. And that scientist was a quiet, patient, meticulous woman who, unlike Zwicky, made almost no enemies at all, and who would spend years carefully measuring something so apparently mundane that no one expected it to overturn our picture of the entire universe. She was measuring how galaxies spin. Her name was Vera Rubin, and in the 1960s and 70s, she set out to study the rotation of spiral galaxies, the great pinwheels of stars like our own Milky Way. A spiral galaxy turns, slowly, majestically, its stars orbiting around the bright, dense center the way the planets orbit around the sun. And here, again, there was a simple and confident expectation about what she should find, an expectation rooted in the same physics that governs our own solar system. In the solar system, the planets closest to the sun move fastest, and the planets farther out move slower. Mercury races around the sun in just 88 days, while distant Neptune takes 165 years to complete a single orbit. This is exactly what gravity predicts. Almost all the mass of the solar system is concentrated in the sun at the center, so the farther a planet is from that central mass, the weaker the gravitational pull it feels, and the slower it needs to move to stay in orbit. The speeds fall off with distance. This is one of the most basic and well-tested patterns in all of physics. So Rubin expected galaxies to behave the same way. In a spiral galaxy, most of the visible matter, most of the bright stars, are concentrated toward the center, in that glowing central bulge, just as the sun holds most of the mass in our solar system. So the stars near the center should orbit fast, and the stars out at the edges, far from all that concentrated mass, should orbit slowly, their speeds falling off with distance just like the planets. That was the prediction. That was what the textbooks said should happen. Rubin built her career on careful, painstaking measurement, and she set out to measure those speeds, star by star, region by region, working outward from the bright centers of galaxies to their faint, sparse edges, expecting to watch the rotation speeds drop off exactly as gravity demanded. They did not drop off. This is the moment the universe changed, though almost no one noticed it at the time. As Rubin measured outward from the centers of galaxy after galaxy, the rotation speeds did not fall. They stayed high. The stars at the faint outer edges of the galaxies, far from the bright central mass, where there was almost no visible matter at all, were orbiting just as fast as the stars closer in. It was as if, in our own solar system, distant Neptune were racing around the sun just as quickly as Mercury, which by the laws of gravity should be impossible, unless there were some enormous additional mass spread far out beyond the visible edge, mass we could not see, gripping those outer stars and whipping them around at speeds that the visible matter could never explain. Rubin found this same impossible pattern not in one galaxy, but in galaxy after galaxy after galaxy. It was universal. Every spiral galaxy she measured was spinning in a way that made no sense, a way that required vast amounts of invisible mass extending far beyond the glowing disk of stars. The conclusion was inescapable, and this time the world could not look away, because the evidence was not one strange cluster studied by one difficult man, but a pattern repeated across the entire sky, in every spiral galaxy anyone cared to examine. Each galaxy, it turned out, is not just the bright disk of stars we can see. Each galaxy is embedded in a vast, invisible sphere of dark matter, a halo extending far beyond the visible edge, containing far more mass than all the stars combined. The glowing pinwheel of stars that we photograph and admire is merely the bright center of something much larger and entirely unseen. A luminous yolk floating in the middle of a dark, invisible egg many times its size. The stars we can see are not the galaxy. They are the small, visible part of a galaxy that is mostly dark. And what holds the whole thing together, what grips the outer stars and spins them so fast, what keeps the entire structure from flying apart, is the gravity of the dark matter we cannot see. Vera Rubin had confirmed, with measurement after careful measurement, what Zwicky had glimpsed decades earlier and been ignored for. The universe is dominated by invisible matter, and yet, in one of those quiet injustices that science sometimes produces, Rubin herself never received the highest honors many felt she had earned. She had provided some of the most important evidence ever gathered for the existence of dark matter. Evidence that reshaped our entire understanding of the cosmos, and the Nobel Prize never came to her. She continued working, mentoring, measuring, advocating for other women in a field that had too few, and she died having transformed our picture of the universe without ever being fully recognized for it in her lifetime. There is something fitting, in a melancholy way, that the woman who proved most of the universe is invisible was herself, in the eyes of the prize committees, not seen clearly enough. The dark matter she discovered hides in plain sight. So, for too long, did she? But here is the thing about a scientific truth. Once the evidence begins to accumulate, it does not stop, and dark matter, once people finally started looking for it properly, began to show its fingerprints everywhere. The galaxy clusters and the spinning spirals were only the beginning, and the next piece of evidence was perhaps the most elegant of all, because it did not rely on the motion of anything. It relied on the bending of light itself. Einstein had shown, early in the 20th century, that gravity is not simply a force that pulls on objects. Gravity is a warping of space itself, a bending of the very stage on which everything moves. And one of the consequences of this is that a massive object bends the path of light passing near it. A beam of light traveling through space near a great concentration of mass will be deflected, curved, the way a straight line drawn on a stretched rubber sheet curves if you place a heavy ball in the middle. This means that a massive object in space acts like a lens. Light from a distant galaxy, passing near a closer massive object on its way to us, gets bent and distorted so that the distant galaxy appears smeared, stretched, sometimes duplicated into multiple images, sometimes warped into great glowing arcs of light. Astronomers can observe this bending directly, and crucially, the amount of bending tells you exactly how much mass is doing the bending, because more mass bends light more. So astronomers turn this into a scale, a way of weighing the invisible. They looked at distant galaxies whose light was being bent by massive clusters in the foreground, and they measured the bending, And from the bending, they calculated the mass of the foreground clusters. And once again, the answer came back enormous, far larger than the visible matter could account for. The light was being bent as if there were vastly more mass present than all the stars and gas could explain. The same invisible mass that Zwicky had found in the motion of galaxies, the same invisible halos that Rubin had found wrapped around the spirals, was now revealing itself a third way in the bending of starlight across the depths of space. Three completely different methods, measuring three completely different things, all pointing to the same impossible conclusion. The universe is full of invisible mass. There is no escaping it. And then came the single most convincing piece of evidence of all, an observation so clean and so striking that it is often called the smoking gun for dark matter. It involves a place where two enormous clusters of galaxies had collided, a cosmic crash on a scale almost beyond imagining. Two swarms of galaxies plowing through each other at millions of miles per hour. This collision, captured by our telescopes, did something remarkable. It pulled the visible matter and the invisible matter apart, separated them, and let us see, for the first time, that they are genuinely different things. To understand why this collision was so revealing, you need to know that a galaxy cluster is made of three things. There are the galaxies themselves, the bright swarms of stars, but they are actually a small fraction of the mass. Then there is an enormous amount of hot gas, vast clouds of it filling the space between the galaxies, and this gas, it turns out, contains far more ordinary matter than all the stars combined. And then there is the dark matter, the invisible component, which outweighs everything else. Now, when two clusters collide, these three components behave differently, and that difference is the key. The individual galaxies, being mostly empty space, mostly sail right past each other without colliding, like two swarms of bees passing through one another. But the great clouds of hot gas do collide. The gas in one cluster slams into the gas in the other, and it drags, and it slows, and it piles up in the middle, heated to enormous temperatures by the impact. The gas gets stuck. It lags behind. So after the collision, the ordinary matter, the gas that holds most of the normal mass, ends up concentrated in the middle, slowed and piled up by the crash. And the question is, where does the mass actually end up? Where is the center of gravity? Astronomers could answer this two ways. They could look at the hot gas directly, glowing in X-rays, to see where most of the ordinary matter was, and they could use the bending of light, the gravitational lensing, to map where most of the total mass was, visible or not. If dark matter were not real, if the missing mass were just some misunderstanding about ordinary matter, then the mass and the gas should be in the same place, because the gas is where most of the ordinary matter is. But that is not what they found. What they found was that the mass and the gas had separated. The hot gas, the bulk of the ordinary matter, was piled up in the middle where the collision had slowed it down. But the gravity, the real center of mass measured by the bending of light, was not in the middle with the gas. It had sailed straight on through, splitting into two clumps that had passed cleanly through the collision and kept going, separating from the ordinary matter entirely. The invisible mass had behaved exactly as dark matter should. It does not collide with itself or with anything else. It does not pile up. It does not drag. It simply passes through, ghost-like, unaffected by the crash that slowed the ordinary gas to a halt. The collision had physically pulled the visible and the invisible apart and laid them out side by side for us to see. The ordinary matter stuck in the middle. The dark matter sailed on ahead. two different substances separated in space. Proof as direct as we could ever hope for that dark matter is real, that it is not a trick of misunderstood gravity, that it is a genuine, distinct component of the universe with its own behavior, passing through everything, including the great clouds of ordinary gas, as if they were not there. By this point, the evidence had become overwhelming and varied, gathered by many methods, pointing always to the same conclusion. The motion of galaxies in clusters, the rotation of individual spiral galaxies, the bending of light by invisible mass, the separation of matter in colliding clusters. And there was more, woven into the largest structures in the cosmos and into the faint afterglow of light that fills all of space, every measurement telling the same story. That faint afterglow deserves a moment of its own, because it is how we pinned the numbers down with breathtaking precision. Spread across the entire sky, in every direction you could point, there is a very faint glow of light, far too dim and far too low in energy for your eyes to see, detectable only by special instruments. It is the oldest light there is, light that has been traveling across space for an almost unimaginable span of time. The faint relic radiation left over from when the universe was young, hot, and dense. And this ancient light is not perfectly smooth. When astronomers map it with great care, they find faint ripples in it, subtle patterns of slightly warmer and slightly cooler patches, like the surface of a pond covered in the frozen record of ripples that passed across it long ago. Those patterns are not random. They are the imprint of sound waves that rippled through the hot early universe. And the exact size and spacing and strength of those ripples depend, with exquisite sensitivity, on what the universe was made of as the waves passed through it. This is the crucial point. Ordinary matter and dark matter affect those ancient ripples differently, because ordinary matter pushes back against itself with pressure, and dark matter does not. So the pattern of ripples in the oldest light is, in effect, a fingerprint of the recipe of the cosmos, a record of exactly how much ordinary matter and how much dark matter were present when the light was set free. And when scientists measured those ripples, with satellites built specifically for the task, mapping the faint glow across the whole sky in extraordinary detail, the numbers that came out matched, with stunning precision, the numbers that the galaxies and the clusters and the bending starlight had been pointing to all along. Several completely independent methods, relying on completely different physics, measuring completely different things across vastly different scales and times, all converged on the same answer for how much dark matter the universe contains. That convergence is what gives scientists such confidence. It is not one strange result that might be a mistake. It is many independent roads, all leading to the same impossible destination, the same conclusion that the universe is dominated by an invisible substance, agreed upon to a remarkable number of decimal places. So scientists did the accounting. They added it all up, every method together, and asked the simplest and most profound question. Of everything the universe is made of, how much is the ordinary matter we can see and touch, and how much is the invisible kind? And the answer is one of the most humbling facts ever produced by science. Everything you have ever seen, every star in every galaxy, every planet, every moon, every comet and asteroid, every cloud of gas and grain of dust across the entire visible cosmos, every atom of your own body, every atom of everyone you have ever known, every atom of the earth and the sun and all the worlds we might ever hope to reach. All of that ordinary matter, the only kind we have ever been able to see or touch or study directly, the only kind we are made of, adds up to roughly 5% of the universe. 5%. The visible cosmos, the entire glowing tapestry of stars and galaxies that has filled human imagination since the first human looked up at the night sky, is a thin, bright skin on something far larger and almost entirely unknown. About a quarter of the universe is dark matter, the invisible substance we have been tracing all this time, 5 or 6 times more abundant than all the visible matter combined. And the rest, the largest share of all, is something even stranger, a mysterious energy woven into empty space itself that we understand even less than dark matter. But that is a horror for another night. For now, hold this. The things we can see are the exception. The darkness is the rule. We have spent all of human history studying the small, bright minority of the universe and mistaking it for the whole. It is worth pausing to appreciate how strange the path to this conclusion was, because dark matter was not discovered the way most things are discovered. We did not see it and then explain it. We never saw it at all. We deduced its existence purely from its gravitational effects on the things we could see. The way you might deduce the presence of an invisible person in a room from the chair that moves and the door that opens and the footsteps you hear on the floor. Hints had appeared even before Zwicky in the early decades of the 20th century, when astronomers studying the motions of stars within our own Milky Way noticed that the stars seemed to be pulled by more mass than the visible matter could account for. An early whisper of the same problem that no one quite knew what to make of at the time. The signs were scattered through the data for decades, in the motions of stars and the swarming of galaxies, small inconsistencies that did not fit, until they accumulated into a conclusion too large to ignore. Dark matter is perhaps the greatest thing humanity has ever discovered, purely by inference, purely by following the gravity, purely by trusting the mathematics over the evidence of our eyes. We reasoned our way to the existence of most of the universe. We have never once seen it, and that in itself is a kind of triumph of the human mind, the ability to know that something must be there in overwhelming quantity, filling all of space, on the strength of nothing but its silent gravitational pull on the few things that happen to shine. So what is it? We know it is there. We know roughly how much there is. We know how it is distributed, wrapped in vast halos around every galaxy, woven through every cluster, threading the entire cosmos. We can map it by its gravity with remarkable precision. And yet, after nearly a century since Zwicky first noticed it, after half a century since Rubin confirmed it, after decades of the most sophisticated experiments human beings have ever built, we still do not know what it actually is. We can feel the pull of the invisible ocean. We cannot say what the water is made of. This is, perhaps, the strangest part of the whole story. We have discovered that most of the universe is made of something, and we have utterly failed to identify the something. It is one of the largest and most stubborn unsolved problems in all of science, a hole in our knowledge the size of most of reality. We can at least say what it is not, and ruling things out has been a long and patient process of elimination. The first and most natural guess was that dark matter might just be ordinary matter that happens to be dark. Ordinary matter that simply does not shine. The universe is surely full of objects that give off little or no light after all. Cold clouds of gas, burnt-out dead stars, dim failed stars too small to ignite, lone planets drifting without a sun. Perhaps the missing mass was just a great quantity of this ordinary but unlit material, hiding in the dark, normal stuff that we had simply failed to count. It was a sensible idea, and astronomers tested it carefully. And it failed. There are several lines of reasoning that rule it out, but the simplest is this. We can measure from the universe at large how much ordinary matter exists in total, of every kind, lit or unlit, and that total is firmly limited. There is simply not enough ordinary matter of any form, glowing or dark, to account for the missing mass. Whatever dark matter is, it cannot be made of the same particles that make up ordinary matter, the protons and neutrons that build every atom of the familiar world. It is not dim stars. It is not cold gas. It is not lone planets. It is something else entirely, a kind of matter unlike anything in the periodic table, unlike anything you have ever touched. Could it be black holes, then? Vast numbers of them, scattered invisibly through space? This idea has been examined seriously, and while certain narrow possibilities remain under investigation, the broad version of it has run into serious trouble because large populations of black holes would reveal themselves in various ways that we do not observe. Could it be antimatter? No, because antimatter annihilates spectacularly when it meets ordinary matter, producing bursts of radiation we would surely have detected. One by one, the familiar candidates fall away, and we are left with the uncomfortable conclusion that dark matter must be a genuinely new kind of particle, a type of matter that exists outside the entire framework of the ordinary world, that does not fit into the careful catalog of particles we have spent a century assembling. A particle that has mass, and therefore gravity, but that otherwise barely interacts with normal matter at all. A particle that can pass through a planet without noticing it is there. Physicists have proposed candidates, of course, and given them names, and the names themselves carry a kind of poetry of desperation. One leading idea is a class of hypothetical particles that would be heavy and would feel only gravity and one of the weakest forces of nature, almost nothing else. Such particles, if they exist, would pass through ordinary matter almost untouched, only very rarely bumping into an ordinary atom, which is exactly the ghostly behavior dark matter seems to have. Another leading candidate is an extraordinarily light particle, proposed originally to solve a completely different puzzle in physics, that might exist in vast enough numbers to add up to all the dark matter despite each one weighing almost nothing. There are other ideas too, stranger ones. Particles that barely fit into our theories at all. But here is the crucial point. Every one of these candidates is, so far, entirely hypothetical. Not one of them has ever been directly detected. They are names attached to possibilities, mathematical guesses at what the invisible ocean might be made of, and the universe has not yet confirmed a single one. The two leading candidates are worth knowing a little better, because they pull the mystery in opposite directions. One picture imagines dark matter as a relatively heavy particle, far heavier than the particles of ordinary matter, that feels gravity and one of the weakest forces in nature, and essentially nothing else. What made this idea so compelling for so long is a striking coincidence. When physicists calculated how much of such a particle should have been left over from the early universe, given the strength of that weak interaction, the amount came out remarkably close to the amount of dark matter we actually observe. The numbers seem to fit almost too well, as if nature were pointing directly at this kind of particle. And for decades it was the frontrunner, the favorite, the thing nearly every detector was built to catch. The opposite picture imagines something almost unimaginably light, a particle proposed originally to fix an unrelated puzzle in the theory of the strong nuclear force, so feathery that each one would weigh a tiny fraction of even the lightest ordinary particle, but present in such staggering numbers that together they could add up to all the dark matter. These would not be caught by the same traps at all. They would require completely different instruments, exquisitely tuned devices searching not for a knock, but for the faintest conversion of these ghostly particles into a whisper of detectable energy. So the searchers are hunting for two very different quarries at once, the heavy and the featherlight, with two very different kinds of trap, and neither has yet revealed itself. The years of silence have been hardest on the heavy candidate, the one that seemed so promising, because detector after detector has searched the range where it was most expected to live and found nothing, narrowing the space where it could possibly hide, pushing some physicists to wonder whether the beautiful coincidence that pointed to it was, after all, just a coincidence. And so attention has begun to turn, more and more, toward the featherlight candidate, and toward stranger possibilities still. Ideas that grow more exotic with each passing year of null results. The honest truth is that we are not closing in on an answer, so much as steadily eliminating the answers we expected, and being forced, slowly, to consider that the real one may be something we have not yet had the imagination to propose. And it is not for lack of trying. The search for dark matter is one of the most heroic and frustrating efforts in modern science. Because dark matter is supposed to pass through ordinary matter almost without interacting, but only almost, physicists reasoned that if they built a detector sensitive enough and waited long enough, they might catch the incredibly rare moment when a single dark matter particle happened to bump into a single ordinary atom inside their instrument. The challenge is that such collisions, if they happen at all, would be staggeringly rare and almost unimaginably faint, drowned out by the constant noise of ordinary radiation that bombards everything on the surface of the Earth. So the searchers went underground, deep underground. They built their most sensitive detectors at the bottoms of old mines and inside mountains, beneath a mile or more of solid rock, using the entire mass of the planet above them as a shield to block out the ordinary radiation, leaving only the ghostly dark matter, which sails through a mile of rock as easily as through open air, to reach the detector. And inside these deep shielded chambers, they placed great tanks of ultra-pure material, often cooled to extreme cold, watched by the most sensitive instruments ever made, waiting in perfect darkness and silence for the faint flash of a single dark matter particle striking a single atom. The lengths to which the searchers go are almost unimaginable. Every possible source of interference must be eliminated, because the signal they are hunting for is so faint that the smallest contamination would drown it. The materials the detectors are built from must be chosen for their extraordinary purity, because even the faint natural radioactivity present in ordinary metals and plastics, the trace radioactivity that is in nearly everything around you and that you never think about, would overwhelm the signal. Some detectors use materials that were manufactured before a certain date, or metal recovered from sources shielded from modern contamination, because everything made in the open air now carries a faint radioactive fingerprint that did not exist before. The detectors are washed and purified and shielded in layer upon layer, cooled to within a whisper of absolute zero, monitored by sensors that can register the tiniest disturbance. And then they sit in the dark, under the mountain, and they listen for a knock so faint it may come only once in a year, or once in a decade, or never. One of the most ingenious ideas in the whole search turns on the seasons, and it is worth understanding because it is so clever. As the Earth orbits the Sun, and the Sun in turn moves through the galaxy's dark matter halo, the speed at which the Earth moves through the dark matter, wind changes slightly across the year. For part of the year, the Earth's orbital motion adds to the Sun's motion through the halo, so we move faster through the dark matter wind and should feel a slightly stronger gusting of it. For the other part of the year, the Earth's motion subtracts, and we should feel a slightly weaker wind. So a true dark matter signal should rise and fall gently with the seasons, peaking at one time of year and dipping half a year later, a subtle annual rhythm that nothing else should mimic. Searchers have looked for exactly this seasonal pulse in their data. This faint heartbeat of the dark matter wind rising and falling as the Earth swings around the sun. And the question of whether anyone has truly seen it remains one of the most argued, most tantalizing, and most unresolved threads in the entire hunt. They have been waiting for a long time. Detector after detector, each more sensitive than the last, has been built, run for years, and has recorded again and again the same result. Nothing. No confirmed signal. The dark matter, if it is the kind of particle these detectors were designed to catch, has refused to show itself, passing through the most sensitive traps humanity can build as silently and invisibly as it passes through everything else. Each null result rules out certain possibilities and pushes the search into ever narrower and stranger territory. The hunters are not giving up. New detectors, larger and more sensitive still, are being built even now. But every year that passes without a detection deepens the mystery and raises a possibility that some scientists have begun, quietly, to consider. What if we have been looking for the wrong thing entirely? What if dark matter is not a particle we have simply failed to catch, but something even stranger, something that does not fit any of our guesses, something we have not yet imagined? This is where the story takes a genuinely unsettling turn, because there is a second possibility, and it does not merely add a new ingredient to the universe. It questions whether we understand the recipe at all. Remember how all of this began. Zwicky and Rubin both noticed the same kind of thing. Objects moving faster than they should, given the visible matter and the known law of gravity. There are two ways to read that. The first way, the one we have been following, is to say that the law of gravity is correct, and there must be extra invisible matter providing the extra pull. That is the dark matter answer. But there is a second way to read it, a more radical way. What if there is no extra matter at all? What if the law of gravity itself is wrong, or at least incomplete, and breaks down in some subtle way over the vast distances and weak pulls found at the edges of galaxies? This is not a fringe notion dreamed up to be provocative. It is a serious scientific idea pursued by serious physicists, and it goes by various names, the general thrust being a modification of gravity itself. The proposal is that the familiar law of gravity, the one that works so beautifully in our solar system and in every experiment we can do on Earth, might change its behavior when the gravitational pull becomes extremely weak, as it does in the sparse outer regions of galaxies. If gravity were slightly stronger than expected in those very weak regimes, then the outer stars would be pulled around faster, and you would see exactly the kind of flat rotation curves Rubin observed, with no need for any invisible matter at all. The galaxies would not be spinning too fast because of hidden mass. They would be spinning exactly as fast as a corrected law of gravity demands. Consider what that would mean if it were true. It would mean that there is no invisible ocean. It would mean that the missing mass was never missing, that the universe is made of exactly what we can see after all, and that our error was not in failing to count some hidden substance, but in misunderstanding the most fundamental force in nature, the force that holds you to the ground, and holds the moon to the earth, and holds the galaxies together. It would mean that for over 3 centuries, since the law of gravity was first written down, we have had it slightly wrong and never noticed, because the error only shows up in the faint outer reaches of galaxies where the pull grows impossibly weak. Both possibilities are profound. Either there is a vast, invisible substance making up most of the universe, a kind of matter unlike anything we know, streaming through everything, or else the law of gravity, one of the bedrock pillars of all of physics, is broken in a way we have not understood for hundreds of years. There is no comfortable option. Either way, we have been deeply wrong about something enormous. For most physicists, the weight of the evidence currently favors dark matter, the invisible substance, over modified gravity. And the single strongest reason is that collision of clusters we discussed, where the mass and the visible matter were pulled apart and seen to separate. Modified gravity has a very hard time explaining that separation, because if there is no invisible matter and gravity simply comes from the visible stuff, then the gravity should stay with the visible stuff, and it does not. The clean separation of the gravity from the gas is exactly what you would expect if there is a distinct invisible substance, and exactly what you would not expect if gravity is merely a modified version of the visible matter's pull. So the balance tips toward dark matter. But modified gravity has its own successes, explaining certain patterns in individual galaxies with surprising precision, patterns that the dark matter picture finds harder to reproduce, and the debate is genuinely unresolved at its edges. The honest state of the science is that we are confident something is wrong with the simple picture of a universe made only of visible matter obeying the familiar law of gravity, and we are not yet certain whether the fix is new matter or new physics. Sit with that uncertainty for a moment, because it is rarer and more profound than it sounds. We are not talking about a small open question at the frontier of some obscure specialty. We are talking about not knowing what most of the universe is made of, or whether we even understand the force that shapes it. This is not a detail. This is the bulk of reality and one of its most basic laws, and on both questions, the honest answer is that we do not know. We have built a magnificent and detailed understanding of the small, bright sliver of the cosmos we can see, and we have discovered, in building it, that the sliver is almost all we understand, and that it floats in a vastness we can measure but cannot explain. The map is mostly blank, and the blankness is not at the edges, where you would expect a map to fade. The blankness is the center. The blankness is most of everything. There is one more thing to say about that great inventory before we go on, because we have so far set it aside, and it deepens the strangeness rather than relieving it. We said that the ordinary matter is about 5% and the dark matter about 1/4, and that the rest, the largest share of all, is something even stranger. That something has a name. It is called dark energy, and it is not matter at all. It does not clump, it does not gather, it does not build scaffolding or hold galaxies together. It does the opposite. It is woven into empty space itself, and its effect is to push space apart, to drive the expansion of the universe faster and faster as time goes on. It makes up the majority of the universe, more than dark matter and ordinary matter combined, and we understand it even less than we understand the dark matter. If dark matter is a substance we can measure but cannot name, dark energy is a phenomenon we can barely describe at all, a mystery wrapped around the largest fraction of reality. We will not chase dark energy all the way down tonight, because it is its own vast and separate strangeness, deserving of its own long exploration. But it belongs in the picture for one humbling reason. When you add it together, the truth is even starker than the dark matter alone suggests. The ordinary matter we can see and touch and study, the only kind we have ever directly known, the kind we are made of, is around 5% of everything. The dark matter, invisible but at least a kind of matter, is about 1/4. And the dark energy, which we can scarcely comprehend, is most of the rest. Which means that of the entire contents of the universe, the fraction we genuinely understand, the fraction that fits cleanly into our well-tested physics, is that small 5%. 95% of reality is made of things we discovered only recently and still cannot explain. We are like cartographers who have carefully mapped a single island and only just realized that it floats in an ocean whose far shores we cannot see and whose depths we have no way to measure. The dark matter is the near water, close enough to study by its gravity. The dark energy is the open sea beyond, and the island, the solid familiar ground of everything we know, is a tiny speck in the midst of it. Now let us bring this vast and abstract mystery down to the most intimate scale there is: your own body. Because dark matter is not only out there, in the distant halos of galaxies and the great colliding clusters. It is here. It is in this room. It is almost certainly passing through you right now. Our galaxy, the Milky Way, is wrapped in an enormous halo of dark matter, that invisible egg around the luminous yolk of stars. And our solar system, with the sun and the earth and you on it, is not sitting outside that halo looking in. We are deep inside it. We are embedded in the dark matter, immersed in it, the way a fish is immersed in the sea. The dark matter halo of the Milky Way passes right through the disk of stars, right through our neighborhood, right through the space between the planets, right through the Earth, right through the chair you are sitting in. The visible matter and the dark matter share the same space. We are not separate from the invisible ocean. We are swimming in it, and have been for as long as the Earth has existed, and will be for as long as it continues to exist. And we are moving through it. The sun, carrying all its planets with it, orbits the center of the Milky Way at an astonishing speed, something like 500,000 miles per hour, sweeping in a great slow circle that takes hundreds of millions of years to complete. As we plow through the galaxy at that tremendous speed, we are plowing through the dark matter halo, which does not orbit in the same neat way the stars do. And so, from our point of view, there is a wind. A dark matter wind, blowing steadily against the Earth as we race through the invisible sea. The same way you feel a wind on your face when you stick your hand out of the window of a moving car, even on a perfectly still day. There is a constant stream of dark matter sweeping through our solar system, through our planet, through everything on it. A silent, ghostly wind that has been blowing for billions of years and that you have never felt and never will. And there is a further, stranger possibility, which makes the wind less steady and more unsettling. We tend to imagine the dark matter in our galaxy as a smooth, even fog, the same everywhere, drifting uniformly. But it may not be smooth at all. When galaxies form and grow, they do so in part by swallowing smaller galaxies, tearing them apart and absorbing them. And the dark matter of those devoured galaxies does not simply blend into a uniform haze. It can remain, for billions of years, in long ribbons and streams, vast rivers of dark matter looping through the larger galaxy along the paths of the smaller ones that were consumed. Our own Milky Way has eaten many smaller galaxies over its long life, and the dark matter from those ancient meals may still be flowing through it in great invisible currents, denser threads woven through the broader sea. And some of those streams may pass directly through our part of the galaxy, through the solar system, through the Earth. So the wind blowing through you may not be a gentle, even breeze. It may at times be a current, a dense river of dark matter drawn from some small galaxy that the Milky Way devoured billions of years ago. its remnants still streaming through space along the path of its long-ago destruction, sweeping now through our solar system and through this planet and through you. You would feel nothing, of course. You never feel any of it. But the thought has a particular chill to it, that the invisible substance passing through your body right now might be the scattered remains of an entire galaxy that died and was consumed before the Earth even formed. Its dark matter still flowing, still moving, still passing through the worlds and the bodies that came long after. A ghostly river of the dead galaxy threading silently through the living present. How much of it is passing through you depends on exactly what dark matter turns out to be, on the mass of whatever particle it is made of. And since we have not yet identified that particle, we cannot give a single certain number. But we can say this: the space around you is not empty of it. By the best measurements of how much dark matter fills our corner of the galaxy, a steady current of it is flowing through your body every moment, particle after particle after particle, passing through the gaps in your atoms, through the spaces between your cells, through the very nuclei of the atoms that make you up, never touching, never colliding, never leaving the faintest trace. Hold your hand up in front of your face. It looks solid. It feels solid. But it is, like all ordinary matter, mostly empty space. And through that empty space, the dark matter pours, unhindered, unfelt, a river of the universe's most abundant substance flowing through the back of your hand and out the other side without your skin ever registering its passage. You are not a solid object to the dark matter. To the dark matter, you are a ghost, and it sails through you as easily as you walk through air. And consider that this works in both directions, which is the strangest part of all. You are transparent to the dark matter, yes, but the dark matter is equally transparent to you. You cannot feel it because you cannot touch it, and you cannot touch it because the two kinds of matter do not interact in any way your body could ever register. When the dark matter flows through your hand, there is no collision, no friction, no faint pressure, nothing. The atoms of your hand and the particles of the dark matter simply occupy the same space at the same time and pass through one another as though each were a phantom to the other. Two kinds of substance sharing a single volume and yet utterly unable to meet. It is the most intimate kind of coexistence imaginable, closer than any touch. The two forms of matter passing through the very same points in space, and at the same time it is the most absolute separation imaginable. Because for all that closeness, they cannot affect each other at all, joined only by the faint thread of gravity and otherwise as sealed off from one another as two separate worlds. You and the dark matter share the same space, the same room, the same body, and you will never feel it, and it will never feel you for as long as you exist. There is something profoundly eerie about this, and it is worth letting it land fully. We tend to think of ourselves as solid, separate, bounded creatures moving through an empty world. We imagine the air around us as the closest thing to nothing, and our bodies as the dense, real, solid things within it. But the truth is almost the reverse. The space around you and within you is not empty at all. It is filled with the most common matter in the universe, a substance that vastly outweighs everything you can see, and it is moving through you constantly, the way water moves through a net. The boundary you imagine between yourself and the world, the surface of your skin, is no boundary at all to the thing that makes up most of reality. It passes straight through, unimpeded. You are, in the most literal physical sense, transparent to the majority of the universe. The dominant stuff of the cosmos does not even notice you are there, and it has always been this way. Every person who has ever lived, Every animal that has ever breathed, every leaf and stone and drop of water that has ever existed on this planet, has had this invisible river flowing through it without interruption for the entire history of life. The dark matter wind blew through the first single-celled organisms in the ancient seas. It blew through the dinosaurs. It blows through you. It will blow through whoever comes after. It is the great constant presence that has surrounded and saturated every living thing, the silent ocean in which all of it has swum, and not one creature in the entire history of the earth ever knew it was there, until in the last sliver of that history, a handful of humans worked out, from the spinning of distant galaxies and the bending of starlight, that we have been immersed in an invisible sea all along. There is a deeper layer to this, and it turns the strangeness into something close to awe, because the invisible matter is not just a passive presence streaming through us. It is the reason we are here at all. It is, quite literally, the architect of everything we can see. To understand why, you have to think about how galaxies came to exist in the first place. The visible matter of the universe, the ordinary gas, did not simply assemble itself into the magnificent structures we see today. The galaxies and clusters and the great cosmic web that threads them together. Ordinary matter, left to itself, would have struggled to clump together, because it pushes back against itself. Gas is hot, and pressure resists collapse, and light pushes outward, and so ordinary matter alone has a hard time gathering into dense concentrations against its own resistance. Something had to provide the gravitational scaffolding first. Something had to build the framework, the wells of gravity into which the ordinary gas could then fall and gather and ignite into stars. And that something was dark matter. Because dark matter feels gravity but does not feel pressure or radiation. Because it does not push back against itself the way ordinary matter does, it was able to clump together freely, gathering into vast invisible concentrations, weaving itself across space into an enormous web of dense regions and empty voids. This invisible web, this dark scaffolding, formed the skeleton of the cosmos. And then, into the gravity wells of that dark scaffolding, the ordinary gas could fall. The dark matter built the framework, and the visible matter filled it in. The galaxies formed where the dark matter had already gathered, the bright, luminous yolks settling into the centers of the dark, invisible eggs that had assembled first. Every galaxy you can see exists because long before it formed, an invisible concentration of dark matter had already gathered there, ready to catch the ordinary gas and cradle it into stars. The visible universe is painted onto a canvas of the invisible. The light traces the dark. The structure we admire is the shadow, cast in stars, of a scaffolding we cannot see, which means that you owe your existence to the dark matter. The sun exists because the Milky Way formed, and the Milky Way formed because dark matter gathered first and made a place for it. The atoms in your body were forged in stars, and those stars could only form because the invisible scaffolding had already built the galaxy to hold them. Without the dark matter, there would have been no galaxies, or at least nothing like the rich, structured, star-filled galaxies that life requires. There would have been no place for stars to form, no furnaces to forge the elements, no worlds to gather out of the leftover dust, no Earth, no you. The invisible majority of the universe, the substance we cannot see or name or catch, is not some irrelevant background. It is the foundation. It built the house that all visible things live in. We are the bright decorations hung upon an invisible frame, and we mistook the decorations for the whole structure because the frame gives off no light. This inverts something deep in the way we think about ourselves and the cosmos. We are accustomed to imagining that the things that matter are the things we can see, that reality is fundamentally the luminous world of stars and planets and living things, and that whatever invisible stuff might exist is secondary, a footnote, a curiosity. But it is the other way around. The visible is the footnote. The invisible is the main text. We, the visible beings made of visible matter, are the rare and delicate exception, a thin, glowing froth on the surface of a vast, dark sea that does the real structural work of holding the universe together. We are not the universe's main event. We are a small, bright, improbable feature of it, made possible by an invisible majority that built the stage on which we briefly stand. And consider what this says about our senses, and even about our science. For the entire history of life on Earth, every creature that ever evolved eyes did so to detect light, because light was useful. Light bounced off food and predators and mates. Light carried information about the small, visible fraction of the world that mattered for survival. Evolution tuned us exquisitely to perceive the luminous 5% and gave us no organ whatsoever for sensing the invisible 95%, because the invisible majority never mattered for staying alive. So we walk through the world perceiving only the thin, bright skin of reality and feeling certain that the skin is everything, because our eyes were never built to tell us otherwise. We are like creatures who evolved to see only the foam on the surface of the ocean, and who concluded, naturally and inevitably, that the foam is all there is. It took the slow, strange, collective effort of science, the careful measurement of things our senses could never perceive, to reveal the depth of water beneath the foam. Our eyes lied to us, not out of malice, but out of irrelevance. The dark matter was never worth seeing, in the harsh economy of survival, and so we never evolved to see it. And so we lived our whole history convinced that the visible was the real. And once you accept that there is a whole invisible majority of the universe, a question arises that some physicists have begun, cautiously, to explore, and it is a question that can keep you awake if you let it. We assume dark matter is simple. We picture it as a single kind of particle, featureless, doing nothing but providing gravity, a dull gray filler that holds galaxies together and otherwise just drifts. But why should it be simple? Ordinary matter, our 5%, is not simple at all. Our small visible fraction is made of dozens of different particles, bound by several different forces, capable of assembling into atoms and molecules and chemistry, and ultimately into the staggering complexity of planets and oceans and living things. All of that richness, all of that structure, emerged from just 5% of the universe. So what reason do we have to assume that the other 95%, the vast invisible majority, is barren and featureless? What if the dark sector, as physicists sometimes call it, is not a single dull particle, but a whole hidden world of its own? This is speculation, and the honest scientists who entertain it are careful to label it as such. We have no evidence for any of it. But it is not forbidden by anything we know, and that is what makes it so unsettling. There could, in principle, be more than one kind of dark matter particle. There could be dark forces, invisible forces, that act only between dark particles, the way our forces act between ordinary particles, forces we would never detect because they do not touch our world. There could be dark matter that clumps and binds in ways we do not expect, forming structures of its own, invisible architectures woven through the same space we occupy, overlapping our galaxies and our world, sharing our space, separated from us not by distance, but by the simple fact that it does not interact with the matter we are made of. Two worlds, the visible and the dark, occupying the same volume of the universe, passing through one another endlessly, each utterly oblivious to the other, joined only by the faint thread of gravity. We would have no way of knowing. A dark structure could be passing through this very room, through this very planet, and the only sign of it, if any, would be the faintest gravitational whisper, far too subtle for us to feel. We do not know if any of that is true. Most likely, the dark sector is simpler than our wildest imaginings. But the mere fact that we cannot rule it out, that there is room in our ignorance for an entire hidden world overlapping our own, is a measure of how little we truly understand about the bulk of reality. We have spent so long assuming the universe is the things we can see that we are only now beginning to grapple with the possibility that the things we cannot see might be just as rich, just as structured, just as full of whatever the dark equivalent of complexity might be, and forever, or at least for now, beyond our reach. The invisible ocean might not be empty water. It might have its own currents, its own weather, its own architecture, all of it hidden behind the simple, absolute barrier that it does not shine and does not touch. What would it mean to finally identify it? That is the great hope that drives the searchers in their deep underground chambers, the dream that keeps them building ever larger detectors despite year after year of silence. To catch a single dark matter particle, to measure its mass and its properties, to finally know what the invisible ocean is made of, would be one of the greatest discoveries in the history of science, comparable to the discovery of the atom or of the structure of the genetic code. It would transform our understanding of the universe at the deepest level. It would tell us what most of reality is, and it might open a door into that hidden dark sector, giving us our first glimpse of the vast invisible world that has surrounded us all along. Or it might reveal that we were wrong about gravity instead, that the law itself needs rewriting, which would be just as revolutionary in its own way. Either outcome would reshape physics. Either outcome would be a moment when humanity finally saw, for the first time, a true glimpse of the 95%. But there is also the possibility that we do not solve it. Not soon. Perhaps not for generations. Perhaps the dark matter, whatever it is, interacts so weakly, hides so completely, that our detectors never catch it, and our colliders never make it, and the question remains open not for years, but for centuries, a permanent reminder etched into the foundation of our knowledge that we live in a universe we do not understand. There is a strange humility in that prospect, and perhaps even a strange dignity. We are a young species, barely a century into knowing that the invisible majority exists at all. It may be that the answer is simply beyond our current reach, waiting for instruments we have not yet imagined, or insights we have not yet had, or minds not yet born. The mystery may outlive everyone now alive, and there is something honest, something almost noble in a science mature enough to say, clearly and without shame, that the largest question of all remains unanswered, that we have found the edge of the ocean and have not yet learned to swim in it. There is a particular flavor to this fear, and it is worth naming, because it is different from the fear of a comet or a collapsing star or any visible threat. Those dangers, however terrible, are at least the kind of thing we are built to understand. They are objects. They are events. They have edges and locations, and we can point to where they are and imagine them coming. But dark matter does not frighten in that way. It frightens in a quieter, more dissolving way, because it attacks not a place, but a certainty. It tells you that the simple, lifelong, unquestioned assumption that the world is the things you can perceive, is wrong. Not slightly wrong. Catastrophically, overwhelmingly wrong, wrong about the majority, wrong about the bulk, wrong about most of what is. And it tells you this not with violence, but with a kind of calm, total finality, the way a quiet voice delivering devastating news is somehow worse than a shout. We trust our senses. We have to. They are the only direct contact we have with the world, and for the entire span of our lives, they have served us faithfully, telling us where the ground is and where the food is and where the danger is, and they have been right often enough to keep us alive. So we come to believe, deep below the level of conscious thought, that what we perceive is what is real, and that what we cannot perceive is, at most, a minor addition at the margins. Dark matter shatters that belief at the root. It says that your senses, faithful as they are, have been showing you a tiny corner of reality and presenting it as the whole. It says that the confidence you feel in the solidity and completeness of the visible world is not earned but accidental, a byproduct of having evolved eyes for the luminous 5% and nothing at all for the dark 95%. The fear of dark matter is the fear of discovering that the floor of your certainty was always a thin board laid across an abyss, and that you have been walking on it your whole life, calling it the ground. And the only way we ever found out is by learning to trust something other than our senses. This is, in a way, the deepest lesson hidden inside the whole story of dark matter, and it reaches far beyond astronomy. For nearly all of human history, to know the world meant to perceive it, to see it or hear it or touch it. What our senses reported was reality, and what they could not report did not exist for us. But the discovery of the invisible majority of the universe was made not by any sense, but by instruments and mathematics. By measuring things our bodies could never feel and reasoning our way to conclusions our eyes could never confirm. We had to learn to believe the numbers over the eyes, to accept that a careful measurement of how galaxies move could be more trustworthy, more real, than the plain visible emptiness between the stars. That is a strange and difficult thing for a creature to do, to override the testimony of its own senses in favor of an abstract calculation. And yet, it is exactly what allowed us to see past the bright skin of reality into the dark depths beneath. The dark matter could only be found by a mind willing to distrust its own perception, willing to follow the evidence past the edge of what could ever be seen. And in learning to do that, we did not just discover dark matter. We discovered something about the limits of perception itself, the humbling truth that our senses, faithful as they are, were never built to show us the whole of what is, only the small, useful corner of it that helped our ancestors survive. And yet, as with every one of the universe's deepest strangenesses, there is another way to hold it, and it is not fear at all. Because the same fact that dissolves your certainty also expands your world beyond anything you had imagined. You thought you lived in the visible cosmos of stars and planets, and it turns out you live in something far larger and stranger and more mysterious, a universe whose true extent your ancestors could never have dreamed. The discovery of dark matter is not a loss. It is a profound enrichment. It means the universe is bigger than it looks, deeper than it looks, more full of unknown things than the most imaginative person who ever lived could have guessed. We did not lose the visible cosmos when we discovered the dark majority. We gained an invisible one, vaster than everything we knew, waiting to be understood. The abyss beneath the thin board is not empty. It is full, fuller than the world above it, and we have only just begun to learn its shape. Look at what that shape appears to be on the largest scales, because it is one of the most beautiful and haunting images modern science has produced. When astronomers and their computer simulations map out how the dark matter is distributed across the entire universe, they do not find it spread evenly like a fog. They find it gathered into a vast, intricate structure, a network of dense filaments and threads, stretching across hundreds of millions of light years, with great empty voids between them, where almost nothing exists. The dark matter forms long bridges and walls and knots, and where the filaments meet and tangle, the great clusters of galaxies hang like glittering dewdrops caught in an invisible web. They call it, fittingly, the cosmic web. And the visible galaxies, all the billions of them, trace out the lines of this web like lights strung along invisible threads, marking the shape of a scaffolding made entirely of the dark. The image is uncanny because the cosmic web looks alive. Laid out across the largest scales of the universe, the filaments of dark matter and the galaxies strung along them form a pattern that looks startlingly like the branching networks we see in living things, like the threads of a vast fungus spreading through soil, or most strikingly of all, like the network of cells in a brain. Neurons connected by a tangle of fibers, with sparks of light where the connections cluster. The universe, on its grandest scale, organized by the invisible matter, has woven itself into a structure that echoes the patterns of life and thought, not because there is any mind in it, but because the same blind physics of gravity, branching and clustering and connecting, produces similar shapes wherever it works, from the inside of a skull to the entire observable cosmos. And the architect of that great web, the thing that drew the threads and built the structure and hung the galaxies along its lines, is the dark matter, the invisible majority, sculpting the largest patterns in all of existence with a hand we cannot see. And the scale of that web is beyond anything the human mind is built to grasp. The filaments of the cosmic web, the great bridges of dark matter along which the galaxies are strung, stretch for hundreds of millions of light years, and between them lie the voids, vast and almost perfectly empty bubbles of space so enormous that a single one could contain thousands of galaxies worth of volume, with almost nothing inside it. Picture the structure of a sponge, or the foam of bubbles in a glass, walls and threads of material surrounding great empty pockets, and then expand that image to the scale of the entire observable universe. That is the shape the dark matter has carved. The galaxies, including ours, cling to the walls and threads, gathered along the dense filaments, while the immense dark voids yawn between them. Regions of such profound emptiness that a traveler crossing one might go for an unimaginable span without passing a single star. The bright universe we know is not spread evenly through space. It is painted onto the thin surfaces of an invisible foam, clinging to the scaffolding the dark matter built, while most of the volume of the cosmos is the great dark hollows in between. There is a vertigo in realizing that this is the true large-scale shape of reality, and that we live not at the center of anything, but on one thread of one filament of one small region of an inconceivably vast, invisible web. We are not at the heart of the cosmic structure. We are a speck on a strand of it, a single bright point among the billions strung along the dark threads. And the threads themselves are only the visible tracing of a scaffolding far larger and almost entirely unseen. The dark matter did not build this web for us, or for anything. It built it blindly, by the simple working of gravity over enormous spans of time, gathering and clustering and connecting until the whole observable universe was shaped into this vast foam of light and shadow. And we opened our eyes, late in the story, on one bright thread of it, and saw only the lights, and called that the universe, never suspecting the dark architecture that held them all in place. So where does this leave us? The small visible beings made of the rare 5%. It would be easy to feel diminished by all of this, to feel that the discovery of the invisible majority has shrunk us, made us trivial, a thin afterthought floating on a sea of stuff that matters more. But that is the wrong conclusion, and feeling it would be missing the deepest meaning of the whole strange story. Because rarity is not insignificance. The opposite often is true. The fact that visible matter is the small exception, the rare froth, the unusual case, does not make it worthless. It makes it remarkable. Out of the entire vast inventory of the universe, only a small fraction is the kind of matter that can do interesting things, the kind that forms atoms and chemistry and complexity, the kind that can build a star or a flower or a thought. The dark matter, for all its abundance, appears to do almost nothing except provide gravity. It builds the scaffolding, yes, and that is no small thing. But it does not, as far as we know, form atoms or chemistry or anything like the intricate structures that fill our visible world. It is vast, and it is essential, and it is, in another sense, simple, possibly featureless. A great gray abundance whose only known talent is to pull. And the rare visible matter, the unusual 5%, is the part of the universe that came alive. It is the part that learned to assemble itself into ever more complicated forms, into the dazzling chemistry of living things, into eyes that can see and minds that can wonder. You are made of the exceptional stuff. The dark matter dominates the universe by sheer quantity, but it is the visible matter, the minority, that produced you and the earth and every beautiful and terrible thing that has ever happened in the history of life. We are not the diminished remainder left over after the real universe took its share. We are the rare and precious flowering that the visible matter, against all the odds, managed to produce. The dark matter built the house, but it is in the small, bright, visible rooms that anything ever lived. And there is a strange poetry in the arrangement, when you stand back far enough to see it whole. The vast, abundant, dominant dark matter, for all its power, appears to be sterile, unable to form the rich structures that complexity and life require. The rare, scarce, minority visible matter is the fertile kind, the kind that blossomed into everything interesting. It is as if the universe poured most of itself into building a quiet, invisible, structural majority whose only role was to make a place, and then took the small leftover fraction and let it run wild. Let it form atoms and chemistry and stars and worlds and eventually creatures who could look back at the whole arrangement and marvel at it. The dark matter is the soil. The visible matter is what grew. And though the soil vastly outweighs the flower, it is the flower that opens, the flower that turns toward the light, the flower that is, in the end, the point of the whole growing. We are the flower. We are what the rare visible matter did with its freedom, the improbable blossoming of the small bright fraction, made possible by an invisible majority content, to do the quiet structural work beneath the surface, never blossoming itself, never needing to. There is a kind of liberation in seeing it this way. We do not need to be the majority to matter. We do not need to be the bulk of reality to be the most interesting thing in it. A single candle in a vast, dark cathedral is not made insignificant by the size of the darkness around it. It is made precious by it. The darkness only makes the flame more striking, the light more valuable, the small, warm glow more worth protecting. We are the flame in the cathedral of the dark universe, the rare luminous exception in a cosmos that is overwhelmingly invisible, and the vastness of the dark around us does not diminish our light. It frames it. It makes it the most extraordinary thing in the room. What then should you do with this knowledge when it comes to you in the quiet of the night? You should let it change the way you see, not by frightening you, but by deepening you. The next time you look up at the night sky and see the scattered stars and the faint band of the Milky Way, you will know that what you are seeing is not the universe. It is the small, bright froth on the surface of the universe, the luminous 5%, the visible lights strung along the lines of an invisible web. You will know that all around those lights, and between them, and through you, flows an unseen ocean that vastly outweighs everything that shines, a substance we can measure but cannot name, that built the galaxies and cradles the stars and passes through your body without a whisper. You will look at the night sky and understand that you are seeing only the tip of it, the visible edge of something far larger and stranger, and that the darkness between the stars is not empty at all, but fuller than the stars themselves. And that understanding, far from making the sky less wondrous, makes it almost unbearably more so. The plain black gaps between the stars, which for all of human history looked like nothing, like simple emptiness, the boring background against which the interesting stars were scattered, turn out to be the main event. The darkness is where most of the universe is. The darkness is doing the real work, holding everything together, shaping the great web, building the structures within which the stars can shine. When you look at the dark spaces between the stars now, you are not looking at nothing. You are looking at the invisible majority of all that exists, hidden in plain sight, the great silent ocean that has surrounded us all along. The night sky is no longer a scattering of lights on an empty canvas. It is a scattering of lights on a canvas that is itself the largest and most mysterious thing there is. Spare a thought before this night is done, for the people who are trying to catch it. Right now, as you listen, in deep chambers carved out beneath mountains and at the bottoms of old mines all over the world, there are detectors running in perfect darkness and near perfect silence, watched over by scientists who have devoted entire careers to a search that may never succeed in their lifetimes. Picture what that work is actually like. A mile of solid rock overhead, blocking out the constant rain of ordinary radiation that falls on the surface of the Earth. A great tank of ultra-pure material, often a heavy liquid, cooled and shielded and monitored by the most sensitive instruments ever built. And then the waiting. Days, months, years of waiting, watching for a single flash, a single faint recoil of a single atom struck by a single passing dark matter particle, an event so rare that you might wait years to see even one, if you ever see one at all. It is one of the strangest and most patient forms of hunting in all of human endeavor. The hunters cannot see their quarry. They do not know its size or its shape, or even for certain that it is the kind of thing their traps can catch. They have built the most exquisite instruments imaginable to detect a creature that may slip through every net, and they sit in the dark beneath the mountains, year after year, watching for a ghost. And when, as has happened again and again, the years pass and no clear signal comes, they do not declare the search a failure and go home. They build a better detector, larger and more sensitive than the last, and they begin again. There is a quiet heroism in this that rarely makes the news, the heroism of people pursuing an answer that may not arrive in their lifetimes, working on a question so large and so hard that any individual career is only one small contribution to a search that may span generations. They are trying to lay eyes, for the first time in history, on the stuff that most of the universe is made of. And they keep at it, in the dark, in the silence, because the question is worth it. Because to finally know what the invisible ocean is made of would be one of the greatest things our species has ever learned. There is something in that image that speaks to the whole human relationship with the unknown. We are a species that cannot leave a mystery alone. We felt the pull of the invisible in the spinning of distant galaxies, and rather than shrug and look away, as the world did for decades after Zwicky, we eventually turned the full force of our curiosity and our ingenuity toward it, and we have been chasing it ever since, down into the deep rock, across the largest telescopes, through the most powerful machines, refusing to accept that most of reality should remain forever beyond our understanding. We may not catch it, but we will not stop trying, and there is something magnificent in that refusal. The determination of a small, recently arrived species to understand a universe that is overwhelmingly invisible to it. And it raises a question that reaches beyond dark matter. A question that should give you a pleasant kind of vertigo as you sit there in the quiet. If we lived for the entire history of our species without ever suspecting that most of the universe was invisible to us, if it took until just the last century to even realize that the bulk of reality lay outside our senses, then how confident should we be that we have now found all of it? How sure can we be that dark matter and the even stranger dark energy beyond it are the last great hidden things, and not merely the first two that we happen to stumble upon? The history of science is a history of discovering, over and over, that reality is larger and stranger than we thought, that there were always more things hidden just beyond the edge of what we could perceive. Each time, we assumed we had finally seen the whole picture. Each time, we were wrong. There is no particular reason to believe we have reached the end of that process now. There may be more invisible majorities still to come, more vast hidden components of reality that we cannot yet detect because we have not yet built the right instrument or had the right idea. Layers upon layers of the unseen, waiting in the dark beyond our knowing. That thought could be terrifying, and in a certain mood it is, but it can also be the most thrilling thought there is, depending entirely on how you choose to hold it. It means the universe is not a closed book that we are slowly finishing. It means the universe is far deeper than we have any way of measuring, full of hidden rooms we have not yet found the doors to. An inexhaustible mystery that will keep revealing new depths for as long as there are minds curious enough to look. We are not running out of universe to discover. We have barely begun. We found, in the last 100 years, that most of what exists was hidden from us, and that discovery, rather than closing the question of reality, blew it wide open. The dark matter is not the end of the story. It is a sign, written across the whole sky, that the story is far longer and stranger than we ever imagined, and that we are only on its earliest pages. Come back now, all the way back, from the cosmic web and the deep detectors and the great inventory of the universe, to the small and immediate fact of your own body, sitting where you are sitting, in this room, in this moment. Because everything we have talked about tonight is not only happening out there, in the distant halos and the colliding clusters. It is happening here. The invisible ocean is not somewhere far away. You are immersed in it. It is flowing through you as you breathe. Think about what you actually are in the light of all this. You are an arrangement of ordinary matter, the rare 5%, atoms forged in ancient stars and gathered into the intricate living structure that is you. And those atoms, solid as they feel, are themselves mostly empty space, vast gulfs between tiny dense nuclei and the wisps of electrons around them. If you scaled up a single atom to the size of a great stadium, the nucleus at its center would be no larger than a grain of rice at the very middle, and all the rest would be empty. You are built of these mostly empty atoms, which means that you yourself, for all your apparent solidity, are mostly empty space, a sparse and delicate lattice of tiny dense points held together by forces with great gulfs of nothing between them. And through all of that emptiness, through the gulfs within your atoms, through the spaces between your particles, the dark matter flows. It does not push against the dense points. It does not need to. The points are so small and the gaps so large that the dark matter passes through the structure of you the way wind passes through a sparse forest, the way water passes through a wide net, untouched and untouching. Here and then gone, a constant silent passage that began before you were born and will continue after. There is an intimacy in that which is hard to put into words. You are not separate from the invisible majority of the universe. You are saturated with it. It is within you as much as it is within the void between the galaxies. The same substance that holds the Milky Way together, the same dark matter that built the scaffolding into which our galaxy fell and formed, the same invisible ocean that fills the cosmos, is moving through the center of your chest as your heart beats, through the bones of your hands, through the very thoughts forming in your mind as you take this in. You are not a solid thing in an empty world. You are a sparse, bright, improbable structure standing in the midst of an invisible sea that flows through you without resistance, joined to the largest structures in the universe by the simple fact that the same dark matter passes through you and through them alike. The boundary between you and the cosmos is far thinner, far more porous than you ever imagined. In the most literal sense, the universe flows through you and has always flowed through you, and you are made of the rare, visible froth on the surface of that flow. And knowing all of this, what is the right way to feel? Not fear. The dark matter has been passing through every living thing for billions of years and has never once done any harm. It does not touch you. It cannot hurt you. It is the gentlest presence imaginable, a silent companion that has accompanied every breath of every creature that has ever lived without ever making itself felt. To be afraid of it would be to misunderstand it entirely. The right response is something closer to awe and to a strange and quiet kind of belonging. Because you are not a stranger in this universe, a small visible thing surrounded by an alien invisible majority. You are woven into it. The same invisible substance that fills all of space fills you. You are immersed in the cosmos, part of its flow, saturated with the same dark matter that shapes the greatest structures in existence. The universe is not out there, separate from you, a vast and frightening place you happen to live in. The universe is flowing through you, this very moment, and you are floating in it, held in it, part of the same single seamless reality that stretches from the inside of your atoms to the edge of the observable cosmos. So let the strangeness become something gentler as the night settles in. Yes, most of the universe is invisible. Yes, we are the small, bright exception, the rare, luminous 5%, floating on an unseen ocean we cannot name. Yes, we have been profoundly wrong for all of human history about what reality is mostly made of. And yes, the great question of what the dark matter actually is remains unanswered, and may remain unanswered for a long time to come. All of that is true, and all of it should fill you with wonder rather than dread. Because the same facts that reveal how little we know also reveal how vast and deep and rich the universe we live in truly is, far beyond anything our ancestors could have dreamed, far beyond what our own eyes were ever built to show us. We live in a cosmos that is mostly hidden, mostly mysterious, mostly waiting to be understood, and we are the part of it that has woken up enough to begin, against all odds, to understand. It is worth pausing, before we let this rest, on how astonishingly recent all of this knowledge is, and on the strange privilege of living at the moment we finally learned it. For tens of thousands of years, human beings looked up at the night sky and saw the stars and wove them into stories, and not one of them, not the greatest astronomer of antiquity, not the most brilliant philosopher of any age, ever suspected that the lights they were gazing at were a small minority of what was actually there. The truth was written into the heavens the entire time, encoded in the way the galaxies move, in the bending of the starlight, available to anyone who could measure it precisely enough. But the measurements were beyond reach, and so the invisible ocean remained a secret, hidden not by any cleverness on its part, but simply by the limits of human instruments, for the whole long span of human history, until a difficult man with a telescope in California, less than a century ago, became the first person who ever lived to glimpse the edge of it. We are among the first generations of human beings who have ever known. Think about that. Of all the people who have ever lived, the overwhelming majority lived and died without the faintest idea that most of the universe was invisible, that they were immersed in an unseen sea, that the cosmos they could perceive was a thin, bright skin on something vastly larger. They were not stupid. They were not blind. They simply lived before the knowledge was reachable. And we, by the accident of when we were born, get to know. We get to live in the first sliver of human history in which our species understands, even partially, the true composition of reality. The first moment in which we can look up at the dark between the stars and know that it is full. That is an extraordinary thing to be given, a gift of timing, a front row seat at one of the great revelations in the history of knowledge. We are alive at the moment the universe is, for the first time, beginning to show us its true scale. It is humbling to think how thin that sliver of knowing is, set against the long darkness of human history. Countless generations of astronomers, some of them as brilliant as any who have ever lived, charted the heavens with care and devotion and never once suspected what they were missing. They were not failing. They were simply early, born before the instruments existed that could reveal the truth. And we happen to be born just late enough, by the smallest of margins on the scale of history, to be among the first who can know. There is no credit in that. It is pure luck of timing, the accident of being alive in the right century. But it is a luck worth pausing over. The quiet good fortune of getting to live at the dawn of one of the great revelations, of being handed, simply by when we were born, a truth that every human before us went to their grave without ever learning. And the revelation is not finished. That is perhaps the most thrilling part of standing where we stand. We have glimpsed the invisible majority, measured its gravity, mapped its web, but we have not yet seen its face. The story is still being written, right now, in those deep underground chambers and on the world's great telescopes, and it is entirely possible that within the coming years or decades, someone will catch the first dark matter particle, or find the flaw in our understanding of gravity, or stumble onto something none of us has imagined. And the next great chapter of this story will open. We are not living after the discovery. We are living in the middle of it, in the long, uncertain stretch between knowing that the invisible ocean exists and finally learning what it is. It is one of the most exciting places in all of history to be standing on the threshold of an answer to a question about the very substance of reality. An answer that has not yet come, but that may come in our time, or in the time of those who come just after us. So gather it all together now, the whole strange and wondrous picture, and let it settle into something you can carry into sleep. Nearly a century ago, a brilliant and difficult man noticed that galaxies were moving too fast to hold together, and concluded, against all the assumptions of his age, that the universe must be full of invisible matter. He was ignored for decades, until a patient and meticulous woman measured the spinning of the spiral galaxies and proved him right, finding that every galaxy is wrapped in a vast invisible halo many times larger than the visible stars. The evidence piled up, from the bending of starlight to the separation of matter in colliding clusters, until there was no escaping the conclusion. The universe we can see, every star and planet and atom of it, is only about 5% of what exists. The rest is the dark, mostly an invisible matter we can measure but cannot name, that built the scaffolding of every galaxy, that holds the cosmos together, that flows through the earth and through your body at this very moment, silent and untouchable. A river of the universe's most abundant substance passing through the empty spaces in your atoms without ever leaving a trace. We do not know what it is. We have searched for it in the deepest, most shielded places we can build, and it has refused so far to show itself. We do not even know for certain whether the answer is a new kind of matter or a flaw in our understanding of gravity itself. The largest question about the composition of reality remains open, one of the great unsolved mysteries of all of science, a blank space at the very center of our map of the universe. And yet, in that blankness, there is not despair but wonder, because it means the cosmos is larger and stranger and deeper than we ever dreamed, and that we, the rare bright exception, the luminous 5%, are alive at the very moment our species first began to understand the true scale of the dark. It is no accident that a thought like this finds you in the quiet hours. In the daylight, surrounded by the solid, visible, reassuring business of ordinary life, the idea that most of reality is invisible has no room to take hold. There are things to do and people to see, and a whole world of tangible concerns pressing in, and the dark majority of the universe is the furthest thing from anyone's mind. But at night, when the noise of the day falls away and the mind is finally free to drift, it tends to drift outward toward the large and strange questions, the ones about scale and substance and what is really out there. And it is in that drifting quiet that the strangeness of the invisible ocean can finally be felt. The awareness that you are immersed in something vast and unseen, that the darkness around you and within you is not empty but full, that the universe is far larger and stranger than the visible world your eyes have always shown you. You do not have to push that thought away, and you do not have to be unsettled by it. You can simply let it be what it is, which is one of the most remarkable things our species has ever discovered, and let it deepen rather than disturb the quiet you are settling into. There is nothing to fear in the dark matter. It has flowed through every living thing that has ever existed, gently, harmlessly, for billions of years, and it flows through you now with the same gentleness, asking nothing, threatening nothing, simply present, the way it has always been present. The silent ocean in which all of life has swum without ever knowing. To lie in the dark and feel yourself immersed in the invisible majority of the universe is not a frightening thing. It is, if you let it be, a strangely peaceful one. The feeling of belonging to something immeasurably larger than yourself, of being woven into the same vast fabric that holds the galaxies, of being part of a cosmos that is mostly mystery and that flows through you as easily as it flows through the space between the stars. So let the day go now. Let the questions soften. You have walked tonight from a swarm of galaxies moving too fast to hold together, all the way down to the invisible river passing through the center of your own chest. And you have seen, along the way, how much of the universe is hidden, and how recently we learned it, and how much remains for us still to discover. That is enough for one night. The dark matter will go on flowing through the earth and through you, whether you think about it or not. The great web will go on holding the galaxies in its invisible threads. The searchers will go on waiting in their deep chambers for the faintest flash of a signal that may or may not come. And the universe will go on being mostly invisible, mostly mysterious, mostly waiting as it has been all along, while you rest. There is nothing you need to do with any of it. You do not have to solve the mystery, or catch the particle, or decide whether it is matter or gravity that we have misunderstood. You can simply let it be, this vast, quiet presence that surrounds and saturates everything, and let yourself be held by the strange and gentle fact that you are part of it, made of its rare, bright fraction, immersed in its invisible majority, floating in an ocean you cannot see, but that has cradled every living thing since life began. The cosmos is flowing through you, softly, silently, as it always has. The dark majority is all around you and within you, and it means you no harm, and it never has. Let your breathing slow. Let your thoughts grow quiet. Let the invisible ocean flow through you the way it has flowed through every creature that ever lived, gently, harmlessly, asking nothing. You are a small, bright, improbable thing made of the rare, visible matter of the universe, floating in a vast, unseen sea, woven into the same fabric that holds the galaxies together. And there is nothing in any of it to fear and everything in it to wonder at. The universe is mostly dark and mostly mysterious, and you are part of it, and it is flowing through you now, as quiet and as constant as it has ever been. The dark is not empty. It never was. And tonight, as you let go of the day and drift toward sleep, it is flowing through you still, gentle and silent and vast, the great invisible ocean in which you have been swimming all along.